Okay, hopefully you got number 3. Here's the answer just to double check yourself. We've got 2 silicon, 3 hydrides, and a fluorine there as a diatom, homonuclear diatom. All right, number 4. The first thing you have to do is number 4 is you read it and you realize you have to write the formula based on what it says, a tricarbon hexahydride. And based on the name, we know that this is a covalent compound. And we're going to first have to write what that is. This is a tricarbon. So it's going to start with a carbon and there's going to be 3 of them and it's going to be a hydride and there's going to be 6 of them. That's what hexa means. And we've got to make these little so that they fit in with what we're supposed to be doing here. Same thing on this. I bet you guys could have figured that one out. This one wasn't too bad. Okay. And now we're going to send it to be what it's going to be broken down to, which is a carbon and a hydrogen. And now because this is hydrogen, it's a homonuclear diatom and we need to put it into a pair. Now the next thing we need to do is balance this out. On the left, we have 3 carbons. So then we just give ourselves 3 carbons. On the left, we have 6 hydrogens. So on the right, we have 2 and they're in pairs. So we do 3 pairs of our hydrogens. And now we are all balanced and we are good to go. Hopefully you got that. That is our first type of chemical reaction. And I'd like to move to the second one, which is formation. Now, formation is the reverse of decomposition. So instead of taking a big one and breaking them into small parts, we're taking the small parts and we're sticking them together. So this one, I think you guys are going to do awesome because if you could do the last one, you should be set. Okay, so the formation, this is going to end up with a magnesium, a carbon, and then 3 oxygen. So we're just going to start on this side with a magnesium. Oops, geez, not a capital G. A magnesium and a carbon and an oxygen. Now we know that oxygen can't hang out all by itself because it's a homonuclear diatom. So we need to have it float as a pair. It always goes together. Now we just need to balance this thing. We're going to put 2 over here. Please balance ahead of me. If you're faster, please do so, which gives us 2 over there. I'm just going to copy it and set it over there. I am so not techie, you guys. And that gives us 2 carbons. And then we have 3 oxygens on this side times 2. That gives us 6. These come in sets of 3 or sets of 2. So we need 3 of them. And that is how you're doing a formation reaction. Let's do the next one. We've got potassium as a K. I keep pointing at my computer like you guys can see my finger. We've got potassium, hydrogen, carbon, and oxygen. You see why we just spent a week nailing down the top 20 on the periodic table because we are just going to hit them so hard again and again and again. Okay, let's just form this thing. I'd like you to give this a go. So pause me, go do it. Ms. Phillips is going to check you, come back, and you'll see the answers here. Okay, pause it. Here are the answers. Hopefully you did what I asked. All right. This is all wonky in our spacing. So all I did was take the individual elements in our potassium, our hydrogen, our carbon, and our oxygen, and I put them on the left side. The next step is to see who is a homonuclear diatom, and we will give them a oopsies, undo, copy that. We're going to do that to our oxygen and to our hydrogen. That's it. And now to balance this out, we've got to put our 2 over here. You can double check these. That gives me a 2 here. Our hydrogen's already balanced. Our carbon needs a 2. And then our oxygen, we end up having a 2 times a 3, which is a 6. So we need to do the opposite over here, a 3 times a 2 to give us 6. We're balanced. Hopefully you guys are good to go. If you still have time, let's keep rolling through these. If not, great, we will finish it next week. Whatever is done in class, I want to see. Okay, complete combustion. Let's just keep going. Complete combustion means you take some sort of fuel, which is usually a carbon-based fuel, and you're adding oxygen to it because we need oxygen to set things on fire. And then what comes out of it is always carbon dioxide and water. That's just what they make. Oops, I do not want that to be little. These are the two things we make. So whenever it says combustion, you're making carbon dioxide and water. And then the next step is we balance this. Our C's are currently balanced. Our H's are not balanced. So we're going to have to put a 2 here. It's going to make a copy a red one. And because we now have 2 H's, we're going to have to give ourselves 2 C's, which gives us a total of 5 O's. This gives us 2. So this isn't going to work out, whereas we're going to have an odd number. So we're going to need to double this, which means we're going to need to put a 4 here. I know there's just so many steps. And then a 4 here. Oops. So now we've got 4 O's, 2, 8, 4. That doesn't make sense, isn't it? Are we doing this right, team? We can all make mistakes, but see, this isn't simplified. So I got to double check. 4 and 4 is 8, 8. No, that's why. This is 8, 9, 10. This is 4 and 10. Okay, we are now balanced. You should end up with a 4, 3, 4, 2. So if you struggle with balancing, sometimes it is just a work. You try it, you erase it, and you do it again. Okay, knowing complete combustion, you are always going to make 1, carbon dioxide, and the second thing is water. Try number 2. Just pause and see what you can do from that. And then come on back and see if you did it right. Okay, I'll just type the answer in and see if you got it right. Okay, you'll see maybe you had to do a little wrestling through on that, but you should end up with a 2, a 13, an 8, and a 10 with carbon dioxide and water on the product side of that reaction. Okay, last one. If you guys are able to get to this, mind blowing. This is amazing because you already had a quiz today. So if you get here, high five yourself. Let's keep going. Now, whenever in your text, they're going to talk about combustion, they're going to very clearly specify if it is complete or incomplete, because there's no other way for you to know. They're going to tell you. Now, incomplete combustion, this is dangerous. This is when people die, when people pass out and have brain damage. This happened in Tacoma all the time. It was so cold out. People started bringing their barbecues into their house, and a barbecue functions with incomplete combustion. And as you can see right here, incomplete combustion is when 2 reactions happen and you're going to burn and have, instead of nice carbon dioxide that our body knows how to process, you're making carbon monoxide, which just makes you kind of feel tired and fall asleep and have brain damage and possibly not wake up. So incomplete combustion is the stuff we do outside. That is what we are burning in our barbecue outside, and it is going to produce carbon monoxide or just carbon. So it's going to be very clear which one it is. So let's do number 1 together. We have CH4 plus O2. So you know it's combustion. You're taking a fuel and you're adding oxygen together, and it's going to make carbon monoxide and water. So all you have to do with number 1 is balance it. That's all you need to do. And I think you can do that without me. So go ahead and get that done. Pause me and balance that thing. So you should have a 2, a 3, a 2, and a 4. Now, if you started that and you're balancing and then you're like, oh, shoot, I need more of those. Then you just go back and you start making it bigger. You should be doing these in pencil and erasing and redoing. The second one is the second way you can have incomplete combustion. And instead of producing carbon monoxide as incomplete, you're just producing carbon. So again, the only thing you have to do in this process is balance it. So I think that's balanced right there. It's a pretty easy one. Carbon's balanced. We have 4 and now we have 4. We have 2 and now we have 2. We are balanced. And that Those are your two options of incomplete combustion. Complete combustion is carbon dioxide and water. And we've also gone over decomposition and formation reactions. This is just the outline of reactions that happen in chemistry. Hold on to this worksheet. You will want to refer to it. I want to see it next week, so please bring it with you. And that's it.